Welcome to Information Technology Video Developer Network. My name is Abdurrashid Hamid. I'm a certified Microsoft specialist working for Cyber Bionic Systematics. The topic of our lesson today is conditional statements. In this lesson, we're going to take a look at conditionals, selection statements. What does conditionals mean? Condition is something that is set for you to match. For example, if you pass your exams, I will buy you a car. That means that if you don't pass your exam, I'm not obliged to buy you a car. But if you pass your exam, which is our conditional, the condition is to pass your exam. Now, everybody knows that, of course, you speak English and everything is okay. But now let's look at how it works here in computing. Here we have a branching operator or conditional operator. This is a construction of a programming language that provides the execution of a specific instruction or sometimes set of instructions only if the logical expression is matched. In this case, we'll say the logical expression is true. Okay, I'll explain that. You'll see true in my diagrams and a lot of things like that. So here we have if, and in this open and close parenthesis, we'll have a condition that should be matched. If this condition is matched, then we'll perform these series of instructions. If this condition is not matched, then we'll perform these series. So we have if, then do this. If not, do this. So if, then, if, else. Else here is like, if this is not true, then we shouldn't go into this instructions. We should perform these set of instructions, or maybe just one instruction. So this instruction, okay? Fine. Let's move on to the next slide and we'll see the type of constructions that we have. Here we have conditional operator if, else. Sometimes it's if, else, and then else at the end. And is put at the end. I'll show you when I come to the examples and the diagrams that we have here. And then we have ternary operators. These are operators that are used instead of this, just to make your work easier, to make your work a little bit compact. Okay? We'll also look at them and see how useful they are. But these ternary operators are used when you have a smaller, like 2 or 3 variables. Okay? If else is more elaborate, it has more functions. Anyway, we have operator of multiple choice, which is switch case. So know that we have 3 types of conditionals, or 3 ways we can write our conditionals. Conditional operator if else, ternary operators, this question mark and this colon, and then of course we have switch case. Let's move on to the next slide and let me show you how the system works. Alright, here we have conditional operator. Implements the execution of certain instructions if the set conditions are matched or if the set conditions are true. The result of a Boolean expression or evaluation must be true. So you remember in our previous lessons we had Boolean expressions or evaluations. They are always either true or they are false. Now let's take a look at this example. Here we've created an integer typed variable and assigned a value of a to it. We also created b and assigned a value of 2 to it. Now this is like our variables, okay? And then we have our condition here. Here we have the conditional word if, and in this open and close parenthesis we write our, let's say, condition, okay? So if a is less than b, console write line, a is less than b. Remember, console write line is what we use to ask the computer to write something for us on the screen, okay? And these are open and close curly braces, which is like the body of our work. So this is like the block of this condition block or condition body. Now here on this diagram I have a condition. If this condition is true, then we perform these set of instructions. If the condition is false, then we go straight down and we go out of the system, or we go to another condition. We go to another set of instructions. But in this case, we only have one condition. If this is true, we write this. If it's not true, we go out. So if the condition is true, we go to this set of instructions. If it's not true, we go out of the block. This set of instructions is where you can see right here. Like, if this is true, then write this, okay? And this is our condition. Condition here, set of instructions here. This is just like a one branch set of instructions. Let's go to the next slide and see our next example. Here we have conditional operators. Depending on the condition, only one of two sets of instructions that are members of the team split is executed. If the condition is matched, then set 1 must be performed. If not, then set 2. This is just what I was talking about like a minute ago. So here we have two instructions. There we had one branch. Here we have two branches, first branch and second branch. The same thing here. We created an int-typed variable named a and assigned a value of 1 to it, b and assigned a value of 2 to it. So if the condition is true match, then we perform the body of the conditional. Let's see. If a is less than b, then we perform this body. We perform this instruction. Else, which means that a is not less than b, we perform this. Okay? Fine. So here in this diagram, you can see the same thing here. This is just like in code, and this is just a diagram that anybody can understand. Condition, a is less than b. So if a is less than b, which is true, set of instructions 1 are to be performed. If a is not less than b, then set of instructions 2, which means it's false, and we perform this and we go out. All right, let me show you this like in an example. Okay, let's move on to our Microsoft Visual Studio and look at this example. This is basically the same example we had there. Here we have also a and assign a value of 1, b assign a value of 2. So we have two integer variables here. And in line 15, you can see we have our condition here. If a is less than b, if the condition is matched, perform the body of conditional of the conditional. Okay. So this is just like when we have a one branch type. This is one branch. We don't have another thing. We don't have else or anything. Let's step this and see what will happen. Stepping is moving one by one. F11 is to go from first step. Let's start and see. Here we have declared our values, and here is our conditional. So if this is true, we should see this on our screen. Let's bring it in. Here we have a is less than b. Of course, a is less than b because a is 1, b is 2. But this is when you have just one branch. Okay? If you have two branches, I showed you also in the presentation, if you have two branches here, let's make this, for example, 3. Okay? Let's make this 3. If you have two variables also, all of int type, variable a and assign a value of 3, variable b we assign a value of 22. Now if a is less than b, then we perform this set of instructions, or just one instruction. We perform this one instruction, sorry. Else, which means if a is not less than 22, we perform this. Let's take a look at this. What do you think will happen? Here we have a is equal to 3, or is the value of a is 3, the value of b is 22. So of course a is less than 22. So a is less than 22, we're expecting something on our screen. What are we expecting? We're expecting a is less than b. Let's try this. You can just press F5 on your screen and run it without having step it. So now we have a is less than b. 1 is less than 22. And that's all. If you step it on the other hand, let's step it here. We just declared our variables, our condition, and it will check it. Is this true or false? So if you hover on it, you will see it's true. A is less than B. So we'll go into this body. Step again, step again. So you see, we moved into this body, and now we are performing this block here. And when you step it again, it will print it out on the screen. But what happens if A is not less than 3? Let's say A is 34. Okay, now we have declared a value of A to be 34, which is greater than 22. So let's step this program and see what happens here. Logically, it should go into this. It shouldn't go into this. It's not supposed to move into this block because this condition has not been met. So if this condition has not been met, it will move out and come into the next condition, which is A is not less than B. Let's step it and see. Here we go. We move. Declaration of variables. Conditionals. Here, A is not less than B. You can see that it's false. So it will not go into this. It will go out and just look at this. You see, it's moving in directly into the else block. This means that this set of instructions, or this instruction that we have here, will be performed. So now we should see A is not less than B. That's very simple. Here we have console read key. This is just like a delay. It is what would make your words that you see on your black and white command box to stay there, and you'll be able to read it. Else, the computer will just flash it, and that's all. You'll not be able to read anything. Let's go back to our presentation and continue what we're doing. Now that we have seen how easy it is to use if-else, let's try and look at the ternary operators. They are almost the same thing. Let's move to the next slide and I'll show you what they are. So here we have a question mark and this colon sign here. These are called the ternary operators, and they act in the same fashion as if and else. So they actually do the same thing, but these guys are not used like in big codes and things like that. They are just made to use your code, to make your code very short and easier. Okay, so here we have the same scenario. Basically, that one was upside down and this is just like in a horizontal manner. We have a condition. If this condition is true, then we perform set of instructions 1. If this condition is false, then we perform set of instructions 2, and then we go out. Notice that after performing set of instruction 1, we don't go to 2, we just go out of the game. Yeah, but if we perform set of instructions 2, we don't go back to 1, we just move straight out again. So it's either we perform this or that. So that was what I was talking about when I said only one of these instructions can be performed at one time. This is for now, okay? So here we have created an int-typed variable named A and assigned a value of 1 to it. And after this comma, we created another variable named B and assigned a value of 2 to it. Then again, we created another variable named C and assigned a value of 0 to it. Now watch this. We have if A in open and close braces is greater than B, then return A. That means return the value of A. Else return B. Okay, so let's take a look at this. We have C, what we created, which is 0, and we assigned this to it. C is equal to, we have A greater than B, then return A, else return B. Console write line C. So whatever our result is here will be put into this and will be printed in our screen. Okay, now look at this. Ternary operator obligatory must return a value, otherwise it causes a mistake. So you must have a value. All right, let's move on to the next slide. Here we have operator of multiple choice or switch operations. Yeah, construction of switch case has several branches, which means you can have branch 1, branch 2, and things like that. So here we've created a string typed variable named b and assigned a value of 1 to it. Here, switch number, we created a type of selector operation, yeah, which is our number here, and we put it in open and close braces. We have case 1 and case 2. In case 1, notice that we have a body here. Okay, open and close curly braces means we have one block here. Open and close curly braces means we have another block here. So we have two blocks, block 1, block 2, or you can say two cases, case 1 and case 2. So here we have case expression 1, case expression 2, branch 1, branch 2. Remember I told you that these double slashes are to just like comment out this. The computer will not need this. This is just for our own explanation, okay? Just to remember what you've been writing or what is there. Fine. So in case 1, what do we have? Case 1 means console write line 1. So in case 1, the console will write 1. In case 2, console will write 2. So we have two options here. Expression, which is our selector. Case 1, if somebody presses, let's say, button 1, first set of instructions, it will print out 1 and then go out. If somebody presses 2, it will perform set of instructions 2 and then go out. Here break means like go out, so we have break, go out, break, go out. So if it somehow performs this, it will not perform this and go. No, it will not show 1 and 2 together. It will just show 1. Break means go out of the scenario. I'll show you this in the examples, and they are really easy. So don't worry. When we go to exercises, you'll see what I'm talking about. Let's move on to the next slide, where we have operator of multiple choice. We have switch operators here. Default block can be present in the construction of switch case. What is the meaning of this default block? Default block means that if none of our cases work, then we have a third block, which is the default block. This is not obligatory, but it's just, a nice way of doing things. So if somebody presses 1, it will print 1. If somebody presses 2, print 2. If, for example, you press, let's say, 3, it will print out a question mark for you. And here, of course, you can write whatever you want. You can write wrong button pressed or something. Here we have our expression. It moves to case 1. If somebody presses 1, we have a lot of cases here. You have two options. This, okay? And the third option is a default option. So if you make a mistake and you don't get this right, it will just move to this. So here we have, let's say, button 1, button 2. So you have two options. If you press button 2, of course, it will perform set of instructions 2 and go out. If you press button 1, it will perform set of instructions 1 and then go out. If you press button 5, just want to try it, it will perform set of instructions 3 and go out. So in this case, we'll have a question mark. Remember this, breaks, okay? And also after breaks, you have a semicolon saying that that's the end of the block. Move out, okay? That is it. And the default block should also be put in open and close braces, just like the other ones. All right? So let's move to our example. Now, what we're going to look at here is basically if-else construction, okay? Here we have two branches, meaning we have if and then else. Also very easy to deal with. Let's take a look at this. Let's step this program and see, but before we step it, let me tell you what is on the screen right now. We have created an int-typed variable named a and assigned a value of 1 to it, b assigned a value of 2 to it. So we have 1 and 2, a1, b2. If I asked you to compare these two, you tell me that, okay, 1 is less than 2 or 2 is greater than 1, but they are not equal to each other. So If the body of if or else blocks consist of a single expression, then you can omit the braces. Here we have just one single expression and we don't need to have curly braces. Let's go back to the second example and I'll show you what I mean. So here you see we have one block, two blocks. That's why we need two expressions, okay? But here we don't need that. Let's go back. Here we don't need that because we just have one single expression. So we have branch 1 and branch 2 if else. If this is true, we do this. If it's not true, we do this. All right. So let's compare 1 and 2. Let's step them and see. Right now, 1 is less than 2, logically. F11, variables created, condition checked, and A is less than 2. It's true. So we'll go in here. And the console will write A is less than B. A is less than B. Simple. What if we change the value of A to, let's say, 4? What will happen? What will happen is we'll not move into this block. We'll, after checking the condition, we'll go straight into else. Every other thing is here, okay? So let's step the program again. Variables created again, check in, and look at this. We go straight out. We go straight out into the second branch, B. And this is what it will print out in the screen. Let's step it again. A is not less than B. Well, of course, A is not less than B. A is 4 and B is 2. So let's take it back as it was and save it. Control S to save it, okay? For future use. Let's move on to the next exercise and see. Here we have conditional if-else with several branches. Well, this is when you have more than 2 branches. You remember the previous example was that of 2 branches. Branch 1 for if, branch 2 for else. Okay? Now, let's take a look at this. We have branch 1 if, branch 2 else if, branch 3 else. Well, this else if you can have as many as you wish. So you can have if, else if, else if, else if, else if, and the last one is else. Else basically means any other thing that does not suit this or this or this, anyone we have, okay? Step in this program, I'll show you how it works right now. Let's press F11 and go. Variables created, an int-typed variable named A assigned a value of 2, B assigned a value of 2 also. Now F11 again. Here we have if A is less than B, which is false. 2 is not less than 2. So we jump. Next, check in. If A is greater than B, it's false. 2 is not greater than 2, which means 2 is equal to 2. That's the only case we have. And that we have else. And we move on and say A is equal to B. And that is what it should print right here on our screen. A is equal to B. Now what happens when we change the values of A and B? Let's say A is equal to 10, B is equal to 2. So A is not less than B, of course, but A is greater than B. So here we're not going to see this. What we should see is A is greater than B, because A is 10, B is 2. Let's step it. Or let's just, okay, let's step it so that you see everything step by step. We have it here. Int 10, 2. A is less than B, false. Next, A is greater than B, true. So we're not going to move out, we're just going to print this. F11 again, and A is greater than B. let me show you something. If you don't want to step it like F11, you remember, just press F5 and it will automatically do everything for you very fast and give you A is greater than B. All right, let's put that back to Control S, ready. Let's move on to the next slide. No, not next slide, next example and see. Here we have the common use of creating some logical expressions, or should I say some useful things here. We have created a string type variable named login and assigned a value of admin to it. So our value is admin. Login is equal to admin. Then we also created a password. String type variable named password and assigned a value of password to it. Well, you can see it doesn't matter here. Anyway, here we're asking the console to ask the user to enter his login. And you see we've left a space here for the user to enter something. And when this user enters a login, what will happen is it will be checked. String users login. We've created a string type variable named users login, and we're going to compare it with what the user entered. Next, we have our condition block here. So this is a practical use of conditionals that we just learned now. If the login is equal to users login. Now don't get this confused. These two are very different. This is the assignment sign, and these double equal to signs, it means equal to in C#. Okay? So if the login is equal to the user's login, what happens is the console will write, please enter your password. So we have console write line, open and close parenthesis, and in double quotes we put please enter your password. So if the person gets the login right, he'll be asked to enter his password or her password. So if the person's password is equal to the user's password, the correct password, okay? If the password the person enters, that's the user's password, is equal to the password that we have here, okay? Password. Then what will happen is the console will tell the person, hello, and you have this open and close parenthesis. We have 0 here. You are logged in. So users login. It will say, hello admin, login. You are logged in. Okay? Else, meaning if the password is not correct, it will print incorrect password. We can write something else here like, please try again. Else, if the person's username is not existent, it doesn't exist in the database, what it will say is no user with such a name. So if we write, for example, John instead of admin here, it's gonna say no user with such a name. Let's run this program and see. F5 straight, and we have enter login. Okay, my login is admin. That's correct. Enter password. My password is, that's a difficult password, and hello admin, you're logged in. It's working. Everything is perfect now. But let's try another scenario. F5 to run the program again. Let's say enter login, and I don't want to enter admin, and I enter, let's say, John. No user with such a name. So John is not the correct name. All right, let's try another thing. Remember, you can still run your program from here. Enter login, admin. Okay, enter your password. Let's say my password is like this, pass, something like this. Okay, now incorrect password. So now you have seen how this works, how to create a program that will read some passwords, accept from the user, checks it, and then checks the password also and give a feedback to the user. Okay, that is it. I told you that if you want to close all but this, you can right click, and here we go. It's easier for you so that we don't have a lot of things here. Let's move on to the sixth example that we have here. Ternary conditional operator. This is what I was telling you about. Remember this question mark and this colon. This is how it works. The same thing with else, if else, if else. We have a logical expression is evaluated or calculated. If the logical expression is true, value of the statement 1 is calculated. Otherwise, the value of statement 2 is calculated. Alright, now let's look at this. Here we've created an int-typed variable named a and assigned a value of 1 to it, b assigned a value of 2 to it, and c assigned a value of 0 to it. So we have assigned the return value of the ternary operator to a variable max, which means we want the evaluation to occur, and then the value of our evaluation will be assigned to max. So here we have assigned it. The same thing you have here, you have it here. We're assigning this to this. The value of our operation will be assigned to max. So here we have max, and we're assigning a value of a is greater than b. If a is greater than b, then return a value of a. If a is not greater than b, then return the value of b. So if a is greater than b, then return a. Else return b. Okay? Here we have it. Console right line max and read key to let it stay there. So what do you think? A is equal to 1, b 2. That means that a is not greater than b. So let's run it and see. 5. We are returning the value of b. Why? Because a is not greater than b. Let's change the scenario. Let's say a is equal to 6. Okay? If a is greater than b, just like we have in this case, then we're expecting a value of a to be returned, or a value of a to be assigned to max, which means when we run this program, we should see 6 on our screen. And here you go, 6. So this is how you can use these ternary operators. Just the same thing, just assign a value that should be returned to something, and then open and close parentheses, write your condition here, question mark, meaning then I want this value, else I want the value of this. Okay? Very easy. Let's move on to our next example. So now here we have ternary conditional operator again. What we are doing here is we have created 4 variables here, all of int type. We've created an int type variable, named it a and assigned a value of 1 to it, created another int type variable named b, assigned a value of 2 to it. The same procedure here, we created c, assigned a value of -5 to it, and created another variable named max and assigned a value of 0 to it. Now this is the case here. This is the tricky part. Here what we have done is we've created this max here, which is here, we brought it back here and assign a value of this to it, but this is not the value. This is like a condition. This is our operator. Okay, now here we have a condition block, we have another block here and another block here, the truth block and the false block. So if a is greater than b, which is true, then we'll carry out this one. We assign the value of a to c, meaning we'll assign 1 to -5, in which case c will not be -5, c will be 1 if a is greater than b. But if a is not greater than b, which is the meaning of this here, this is else. Okay, else. So else assign the value of b to c, meaning assign 2 to c, instead of minus 5. If this is the case, we'll see 2 instead of minus 5. And again, here we ask the computer to write line max, meaning show us the value of max. And then after that, show us the value of C. Computer or console, write line maximum, computer or console, write line C, the value of C. So let's look at what will happen. Let's analyze it first and then step the program. A is greater than B. 1 is greater than 2. This is false. So we're not going to perform this, we're going to perform this. So in this case, C will have the value of B, meaning C will not be equal to minus 5, C will be equal to 2. But when we run the program, what will happen is we'll have two numbers displayed, the value of max and the value of C. Let's step it first before running. To step your program, remember F11. So here the value of A is equal to 1. The value, you see, value of B is equal to 2. Value of C minus 5. Value of max 0. But now everything changes here. This case, we have A is greater than B. 1 is greater than 2. It's not true. It's false. So if it's false, we're not going to perform this operation. We're going to perform this operation. So here we see the value of C has changed from minus 5 to 2. And the value of B has been assigned to the value of C. So C here is minus 2. And the value of max here is also 2. Because we asked the computer, if A is greater than B, then assign the value of C to B, and then assign the value of B to max. So first C is equal to A, only then max is equal to C. Now, we have tried to assign the value of C to A first. It didn't work because A is less than B. It's not greater than B. So first we check that, and then we assign the value to B. Let's keep on stepping. Here you can see we have 2, 2, meaning console write line, the value of max is 2. Why? Because we have assigned the result of this to max, and the result of this is C is equal to B, or C has been assigned the value of B. So if B is 2, C is equal to 2 also, and we return this value to max. So meaning B is equal to 2, C is equal to 2, max is equal to 2. So that's why we have 2 here, the value of max, and 2 here, the value of C. Let's change it and see what happens. If we change this, for example, to 3, now we have a different scenario. Instead of false, we'll have true here, because yes, 3 is greater than 2. So let's run the program step by step. Now here the value of A is 3, the value of B is 2, the value of C is minus 5, and of course the value of max is 0. Look at this. The value of B is 2. Value of A is 3, which makes this condition true because A is greater than B. Now if we move to C here, C has been assigned the value of A. Why? Because the condition is true. If A is greater than B, then assign the value of A to C. So C has been changed from minus 5 to 3. Else do this. But we didn't assign the value of B to C because the condition has been met. The condition is true. So here C is equal to 3 and the value of B is equal to 2. So what do you expect here? Let's keep on running. So you see here we have 3, 3. Console write line, the value of max is 3 and the value of C is also 3. Simple, yes? It's very easy. All right, let's close this example and move to the next example, which is also very easy. Here is a practical application of what we have been learning today. We've created a string typed variable and named it @string and assigned a value of hello to it. And you can see I have a little space here, meaning between hello and the other word that we'll have later, there will be a space. So leave this space and you'll have a space between your words. Then we write console write line, enter your login, which means when we run the program, we'll see enter your login. Okay? Hello, enter your login. So we created another string here in line 17. We created a variable, a string typed variable named login and assigned a value of console read line to it. So here what we're doing is we're asking the console to read the input of the user. That's to accept the input of the user. And then we created on line 21 a string typed variable, and this sign here is concatenation with assignment. Okay? Concatenation with assignment. Remember, concatenation is putting two things together, like 1 plus 1 will just have 1 and 1 put together. So 1, 1. Here what it means is we're trying to put the login with admin together. So login is equal to admin. If login is equal to admin, then administrator will be displayed. Else user will be displayed. Now we have console write line @string, which means we want the console to write what we have here. Let's run the program and you'll understand what I mean here. Here what we have is enter your login. You see it here. Console write line, enter your login. So what is our login? Our login is, let's say, admin. Okay, have it here, admin. So we write admin, enter. See, hello administrator. If it is admin, it will be administrator. Else it would be user. So let's close this and write something else, not admin. Run the program, enter your login. Let's say Mark, for example. Enter. Hello user. Why? Because we don't have Mark here, we have only admin. So you see how this is created. Now that hello you saw here, it's the beginning of it. It takes this and whatever the user puts here and displays it. Hello admin or hello user. These are how we can use the ternary operator to create things like this. Now let's go to the next example and I'll show you even something more interesting. In this example, what we have is very similar to the previous examples. Here we have 3 variables. We've created 3 variables. Here in line 11, we created an int-typed variable named a and assigned a value of 1 to it. In line 12, we've created a double-typed variable, named it b and assigned a value of 0.0 to it. In line 13, we created an int-typed variable, named it max, but notice that we haven't initialized this, meaning we haven't assigned a value to this. It has been created, but it hasn't been assigned any value. Now I want you to remember the difference between int and double. Int is where we have whole numbers, whilst double is where we have fractional numbers. So here we have 0.0. We can have 1.2, and so on and so forth. Now, here, these statements should be of the same type. What does this mean? This means that double and int should be of the same type. We should somehow convert them and put them together. Now, in line 17, we assign the value of this operation to max. What is this operation? We have a condition here. We have our if block here, then do this, else do this. Okay? So, here, if you remember, is a type of explicit conversion. Now, look at this. If A is greater than B, then return the value of A to max, meaning like take this A and put it to max if A is greater than B. Else, return the value of B to max, in which case this is not true. Now, you can do it this way, or even in an easier way, you can do it like this. Here we also assigned the value of our operation here to max. And we have a condition part here. Here we have the true block, and here we have the false block. False block, true block, conditional block. So, if A is greater than B, return the value of A to max. If A is not greater than B, then return the value of B, but the value of B is in double. So return the value of B in int to max. So you first convert it to int. After conversion to int, then you assign it to max. Now, here we have A is equal to 1, B is equal to 0. This means that A is greater than B. Let's step the program. The value of A is 1. Value of B is 0. Value of max is 0 because we haven't assigned anything to it. So here, A is greater than B. Well, of course, 1 is greater than 0. So this is true. If it is true, meaning that we'll take the value of 1 and put it here. So the value of A is 1. That's why the value of max has changed to 1. The second way of doing it is the same thing here. The value of max is 1. Why? Because the value of A is greater than the value of B, which makes our condition to be true. But what if we change the value of, let's say, B, and make it 2.3? Okay, let me just show you how this works. Make it 2.3. Let's close this and step the program again. So here the value of A is 1. The value of B is 2.3. Step in it. The value of A is 1. The value of B is 2.3. A1, 2.3. So is A greater than B? No, it's false. You can see it right here. We have a hint here. It's false, meaning that we will not return the value of A to max, but we'll return the value of B to max. Okay, but look at this. Max has a value of 2, not 2.3. Why? Because we have this int here. It's like we're trying to convert the value of B, which is in double, into the value of max, which is of int type. Remember, int type only holds some whole numbers, while double can hold fractional numbers. So what happens if you're converting from double to int? You lose your precision. You lose this 0.3 and you only take 2. The second way of doing it will have the same result. It's false, and here the value of B is 2.3, but the value of max is 2. Why? Because we have converted the value of B, 2.3, into an integer value. into an int value. So int cannot hold 0.2, 0.3, 0.4. It cannot hold fractional numbers. So it is converted into int, and we lose our precision, and we have max is equal to 2, meaning that we only have whole numbers here. Let's move on to the next example. Let's just close this program. What do we have here? We have also a conditional type, ternary conditional operator, nested ternary operators. What is this and why do we use it? It's very easy. Let me show you what I mean. Here what we're trying to do is we're determining quadrants where a given point is situated. But for simplicity, we agree that the point does not lie in the center of coordinates. Okay? Let me just zoom out a little so that you can see everything. So, here we have created an int-typed variable named x and assigned a value of 10 to it. We created another int-typed variable named y and assigned a value of -5 to it. It is not recommended to make nested ternary operators because it impairs code reading. We don't recommend this, but you should learn it too. So, here we have created a string-typed variant, a string-typed variable named quadrant, and assigned this ternary operator to it. This is our ternary operator block. But in this block, we also have our conditional statement here. We have another conditional statement here. We have, in short, two blocks here, two ternary blocks. This is the truth block, in which case if this is true, we'll move here. If it is false, we have our false block here. So now what we are going to do is go into the conditional block. X is greater than 0, meaning that x, which is 10 is greater than 0. This is true. If this is true, then we move into the truth block, this. But our result would not only depend on this condition. It also depends on y, because we have y-axis and x-axis. So y is greater than 0, but that's not true. Y is equal to, or y has a value of -5. So even in this truth block, we have true, false, true, false. So if this condition is true, we'll move into this block, and then we check this. If this is true, then we take our first quadrant. If this is false, we take our second quadrant. So always remember that if x, our first condition, is true, we move in here. If our first condition isn't true, we move in here. But then again, the second condition depends on the first condition, because we have to first know where we are moving to, either here or here, and then in turn the second condition also determines where our point is going to be. Meaning that after determining that we are here, we have to determine if we are here or here. The same thing here. After we determine that we are here, this condition will determine if we're in the second quadrant or in the third quadrant. So let's step this program and make it easier for you to understand. X is equal to 10, y is equal to -5, and we move in here. X is greater than 0. It's true. So we move in somewhere here. But y is not greater than 0. So we're not going to move to the first quadrant, we're going to the fourth quadrant. That's correct. Now, let's see if we have the answer. Fourth quadrant. We're correct. Again, If we change the value of y and make it, let's say 3, which is also greater than 0. So let's step the program again and see. Value of x is 10, value of y is 3, x is greater than 0, it's true, y is greater than 0, it's true. So what do? X is greater than 0, it's true. We're here in this block. Okay? Not here, we're here. But then again, y is also greater than 0, meaning it is true. So we're here. First quadrant. Let's step up and see. We're in the first quadrant. But what if x is not greater than 10? Not greater than 0, sorry. Let's make x minus 5. Minus 5. And step the program. So x minus 5, y 3, x is greater than 0, it's false, meaning we're going to jump here, not here. We're not going to be in the truth quadrant, we're going to be in the false block. So we're somewhere here. Now we check, is y greater than 0? Yes, it's true. So we're in the second quadrant. If it were false, we'll go to the third quadrant. Let's step up and see. Second quadrant. What if y is also not greater than 0? Y is, let's say, minus 3. What will happen is, we'll check, is x greater than 0? No. We jump to this false quadrant. Okay? First block. And then we check y. Is y greater than 0? No, it's false. So we're going to be in the third quadrant. Let's step it. Here we have x is greater than 0, false. We jump here. Y is greater than 0, false. Third quadrant. And we have third quadrant here. So this is basically how this works. You can do it like this, or like this, or like this. They are all the same thing. They have the same procedure. You can either do it like what we did here, or you can create or assign the value of our ternary operation to quadrant. Here we are checking x is greater than 0. If it's true, we move in here. If it's false, we move in there. And y is greater than 0. If it's true, we have this. If it's false, we use this. Here, if x is not greater than 0, we move in here and we check y. If y is greater than 0, second quadrant. If y is less than 0, third quadrant. The same thing here. What is missing here is just the open and close parentheses. You see here we have more open and close parentheses. Here in this condition block we have open and close parentheses. Here also, whilst here we don't have open and close parentheses, and here we just have one serving everything here and another one serving everything here. And in this case we even don't have any open and close parentheses here. So just make your choice, and anyone that works for you is fine. In this example, we're going to take a look at how shops and other places that sell goods and services can calculate discounts. This is one of the ways they can just calculate discounts very fast. Look at line 11. In line 11, we have created a double-tapped variable named quantity and assign a value of 10 to it, meaning quantity of products purchased. Then in line 12, we created a double-tapped variable also named price and assign a value of 100 to it, meaning that the price of a unit of a product is 100, maybe dollars, pounds, anything can go here. Then in line 13, we created a double-tapped variable also and named it discount, assigned a value of 0.75 to it. Now 0.75 technically translates to 25% discount. If you buy a pen from me and I multiply the price of the pen, let's say the price of the pen is $100, and I multiply the price of the pen by 0.75, what you will pay is $75, giving you a discount of 25%. So, in line 14, we created a double-typed variable named cost, but we haven't assigned any value to it. So, we just leave it like this for now. We'll assign the value in the next line. So, here we have, in line 18, assigned a value to cost. The value we are trying to assign to cost is a calculation, an evaluation or ternary operator here. This has three parts. Here we have the conditional block. This condition has to be matched. If this condition is matched, then this operation or the true block will be performed. If this condition is not matched, then the false block will be performed. So let's try and read this line and see. We assign the value of our ternary operator to cost, but what is in this block here? How you can read this is very easy. If quantity is greater than or equal to 10, then perform this. Quantity multiplied by price multiplied by discount. But if the quantity is not more than or equal to 10, then we perform this. We only multiply the quantity by price, thereby not giving results. Then in line 20, we ask the computer to write this line out. The total cost of the goods is, here we have in open and close curly braces, 0, and I just added this USD just to make it easier for you to understand. Then here we have costs after this comma. What we are doing here is we are taking the value of cost and we are inputting it into this curly braces. So whatever the result is here, whatever the value of our operation, we take it and we put it into this block. So let's run this program and see. Of course, if the quantity the person buys is 10 and each product costs $100, what we're expecting to pay is $1,000. But then again, $1,000 multiplied by 0.75, which is our discount, then the person should pay $750. Let's run the program and see. F5. The total cost of the goods is $750. Okay. What will happen if we change the value of 10? Let's make the value of 10 9, for example. If we change the value of the quantity to 9, what will happen is there will be no discount. Since the quantity is not greater than or equal to 10, then we'll not go into this truth block, we'll move into the block of false operations, since it's not up to that. Let's step this and see. F11, quantity is 9, as you can see here, 9.0, since it's double. And here, quantity is 9. Quantity greater than or equal to 10, it's false. So since it's false, it's not going into this block, it's going to jump into this block. Thereby, calculating as follows. Quantity, which is 9, multiplied by price, which is 100, so we should see $900 here. The total cost of the goods is $900 US. So you can see how these shops can calculate discounts very easily. Let's move on to the next block or next example and see what we have here. In this example, we're going to take a look at the use of the multiple choice operator or switch case. So here basically what we're going to do is we're going to give the user a chance to enter either one number or the other and print out his number on the screen. And in case the user doesn't choose one of the numbers we offer, we also created a default block which will tell him something. So let's go into this and you'll understand what I mean. Here you can see in line 12, what we are doing basically is we are telling or printing out on the screen, and the user will see enter number 1 or 2. So he has two choices, either to enter number 1 or 2. Then in line 15, we're accepting the input of the user. We create a string type variable named number and assign the input of the user to it. So if the user enters 1, 1 will be assigned to number. If the user enters 2, 2 will be assigned to number. Then in line 21, we create a construction of multiple choice or switch choice. Here we have, this is the construction of a multiple choice. And in line 29, what we are doing is we are creating, that is in the body of the switch case, we are creating two cases with expressions 1 and 2. So we have 29 here, we create case 1, and in the body of case 1, we ask the console to print out number 1. And after printing out number 1, you see this break here, it means we're exiting the case. Then in lines 35, we're creating the second case. Now, after the second case, in the body of the second case, we're asking the console to print number 2, just 2, okay? After 2, we have a break and go out. Then in line 44, we create a default block here. You can see our default block here. So if the user enters 3 or 0 or 5, the console will write you entered a number which is not 1 or 2. So the user in this case has only two choices, either 1 or 2, or to enter any other number and get this message. Let's run this program and see how it works. F5. So we have it here. Enter number 1 or 2. Let's say I enter 1. 1 is printed. Well, you can change this 1 to anything you want. You can write, for example, you have entered number 1. And let's copy this here. Control C to copy, Control V to paste, and we have changed it a little bit now. Let's run the program again. Enter number 1 or 2. 1. Enter. You have entered number 1. Let's run it again. Enter number 1 or 2. Enter. You have entered number 2. But let's try and run it using, let's say, number 3, which is not in our cases. You have entered a number which is not 1 or 2. Now the multiple choice operator or switch case isn't restricted to 1 or 2 cases. You can have a lot of cases. For example, here, just like in the previous example, we're asking the user to enter a number. In this case, enter a number of day of week. 1, 2, 3, 4, 5, 6, or 7. So he has 7 options here. And maybe you can also somehow create a default, like here, default, okay? So you can have 8, 9, 10, any amount of cases you want. Then in line 13, we create a string type variable named myDay and assign the value of the user's input. So if the user enters 3, what's going to happen is 3 will be assigned to myDay. Okay? But now, myDay and 3 are two different types. myDay is in the string type and these digits are of int type. So we have to do a conversion. Convert a value of a string variable myDay to an integer value and store it in a variable named myDay of int type. So here in line 18, we created an int type variable named day and assign with conversion. This converts a base data type to another base data type. If you don't know what something is, or you are trying to look for example, console or convert, just hover on it and it will show you what that word or keyword is. Then convert to int 32. Then in open and close parentheses we put myDay. So we want to convert myDay into an int 32-bit int. In line 20, we start our switch case. We create a switch case construction named day, of course. So here in line 22, we start writing our cases. Case 1 is console write line Sunday, meaning if the user enters 1, Sunday will be displayed. 2, Monday. 3, Tuesday. 4, Wednesday. 5, Thursday. 6, Friday. 7, Saturday. Now, if the user enters any number which is not 1, 2, 3, 4, 5, 6, 7, then we have also created a block of default here. So the console will write, you have entered a non-existent day of week. So you see we can have a lot of choices. Let's try this and see. Let's run it and see what will happen. Here we have enter. Let me just show you where it is. Here we have enter a number of day. 1, 2, 3, 4, 5, 6, 7. The same thing we have here. Now, if I enter 4, Wednesday. Let's close that and play it again. Let's say 6, Friday. You see? 5 is Thursday. Let's try 5. 5, Thursday. Very easy. What if somebody doesn't enter the correct number of day or the specified number of day? Let's say 9. You have entered a non-existent day of week. So the computer doesn't know this number. We haven't assigned any value to this number. So this is how multiple case operations can be created. Let me show you another application of the multiple choice operator. In this case, we are going to take a look at something called falling. Now, here in line 12, as in the previous examples, we are giving the user an option to enter a number of day of week. And we have 1, 2, 3, 4, 5, 6, and 7. So he has one of these 7 options. Then in line 14, we created a string typed variable named day and assigned the value of the user's input to day. So whatever the user inputs here will be applied to day. So now we have on line 16 created a switch selector, or this is called the selector expression, because from here in the body you have a lot of cases you can select. These cases are called constant selectors, constant cases. Why? Because they are constant. The numbers don't change here. So you have to choose one of these. Now, in lines 19, 20, 21, 22, 23, 24, 23, sorry, we created 5 cases and numbered them 1, 2, 3, 4, 5. Now, for empty case operators, falling from one operator to another is allowed. What is the meaning of this falling? Falling simply means if the user enters any of these empty case operators, we will just fall down to this block, and this will be displayed. Not Monday, Tuesday, Wednesday, Thursday, but just this will be displayed. So this expression here will be applied to all of these 5 constant cases. And after that, we have a break and we go out of the case. So after the falling, what we have here is we have constant cases 6 and 7. So for these cases, we have another body. Here we have an expression, the day of week is a weekend. So here, working day and weekend. If the user enters a number which is not part of 1 to 7, what will happen is we'll go into the default block. Here in the default block, what's going to happen is on the screen, you have entered a non-existent day of week will be printed. Now let's run this program and see if it works. We have enter a number of week 1 to 7, enter a number of week 1 to 7. So let's say we want to enter number 3, and what we're expecting is this day of week is a working day. So let's enter 3 and enter. This week of day is a working day. If we try to enter number 5, we'll receive the same message. The message doesn't change. 5, enter. Next, let's try to look at 6 and 7. Let's just look at 7, for example, to save our time. When we enter number 7 and press enter, this week of day is a weekend. Of course, that's the message we were expecting. What if we enter number 8, which is not part of our case? 8, enter. You have entered a non-existent day of week. So you see, this is one of the applications of our multiple choice operator. In this last example, what we're going to look at is a practical application of the multiple choice operator, and I guess everybody is familiar with this. Here we are using how a coffee machine can work, how you can give somebody some options and he will choose it and you'll calculate the amount he has to pay. So in line 12, we're writing a line here. You see console write line. So this message will be printed first on the screen, and then another write. This message will be printed. So if you run this program, what will happen is you'll see this message and this message. This message first, then we have this message second. Now, in line 16, we created a string typed variable named coffee and assigned it the value that the user inputs. So if the user or customer chooses 1, then 1 will be assigned to coffee size. If the user chooses 2, then 2 will be assigned to coffee size, and 3 also. Now, in line 18, we created an int-type variable named cost and assigned a value of 0 to 8. So, in line 22, what we're doing is we created a switch case expression. Here we have switch selector expression. This selector expression is used to give somebody some choices. You have 3 choices in this case, case 1, case 2, case 3. Now, in the body of this switch case or in the body of this selector operation or selector expression, what we have here are 3 choices. Then, of course, we have a default block. In line 24, we have case number 1. Case number 1 is taking the value of cost of the small cup coffee, small size coffee, which is 25. So here we have cost, which is 0, plus with assignment, which is addition with assignment, 25. So 0 plus 25. Let's say 25 cents. So 0 plus 25 cents is 25 cents. And after this, we break, we go out, and we print cost. If cost is not equal to 0, then console, right line, pay the amount in cents. This amount, this 0 you are seeing here, will take the value of cost and put into it. But this is only when the cost is not equal to 0. And of course, we'll have thank you written below it. But let's take a look at case 2. In line 27, we have case 2. How does case 2 work? Why is it 25, 25? A small size cup and a big size cup cannot cost the same. So we have in line 27, we created case 2, and we take the value of cost. We add with assignment 25. So 0 plus 25 cents is 25 cents. But then look at this. We have go to case 1. We don't go straight to break. We go to case 1. So you go to case 1 and you add 25 to our cost 25, making it 50. So after case 1, we break, we go out, and we print the same thing. Pay 50 cents, which is the cost. Okay? We take the cost and put it here. Now, let's step this program and I'll show you practically what it means. Let's just bring this in. Here we have the choices and our message. As you can see here, it has printed coffee cup sizes: 1 small, 2 medium, 3 large. Please make your choice. Okay? So let's choose 1. Enter. 1 minute. Let's choose 1. Pay 25 cents. Thank you. If we choose 2, what it's going to do is it will go to case 2, cost, which is 0, plus with assignment 25. So now we have 0 plus 25 cents, 25 cents. But then again, we go to case 1 and we add cost, which is 25 cents plus 25 cents, 50 cents. So let's run number 2. 2. Pay 50 cents. In case number 3, it's the same thing. We have cost, which is equal to 0, and we add with assignment 50. So we now have 50 cents. Then we go to case number 1. Go to is like jump to or go back to number 1. Jump to a specific place. So go to case number 1. If we wrote go to case number 2, it will not go to 1, it will go to 2. But we don't have a break here, so we go to case number 1 and we add 25 to 50. So in case 3, what we are supposed to see is pay 75. 50 plus 25 cents. Case 3. Enter. Pay 75 cents. Thank you. What if somebody chooses 4 or he doesn't choose the correct one? This is where we have our if-else conditions. Yeah. So if cost is not equal to 0, we calculate the cost and input it here and write this message on the screen. Else, if cost is equal to 0, write please repeat your choice. So let's see. Let's say 5. Wrong choice. Please choose 1, 2, or 3. Please repeat your choice. So here basically we have if. On default, we have if the person doesn't choose case 1 or case 2 or case 3, what the console will write is the wrong choice. Please choose 1, 2, or 3. And then it will also write, please repeat your choice. Very simple. So this is how some of these machines work, and I hope you understand it and you'll take some time to practice this. Here, our lesson on conditionals end. I hope you have learned something, and I want to thank you for your time and attention. See you soon.